So for this next example, we have this data set. We have a stats exam and an algebra exam right here. And we're supposed to find the mean and the range for each data set. So let me go back here and let's remind ourselves mean would be equal to average, and then it would be B2 colon B11 in this example. And then the range would be equal to max B2 colon B11, close your parentheses, minus min B2 colon B11, close your parentheses, enter. And then what I can do is I can just take those two cells, highlight them, and drag across, and then look, they're the same. That's not good. Here, I'm going to copy and paste this in. Okay. So this was for stats, and this was for algebra. The two exams have exactly the same mean and range. That's what we noticed, right? But look at the dot plot, which I did right down here. But the two exams are not the same. Look, algebra is much more packed together, look at that, than stats. And we need a number that will measure that spread, i.e. packed in quality for us. Okay? And range is not cutting it, and that's what we're learning. Range is not a good enough measure of spread for us. It's easy to calculate, but doesn't work very well. All right, so that leads us to the big kahuna, namely standard deviation. Okay, so range alone is no good. So what we're going to do is we're going to find, and we're going to do this by hand, and we're only going to do it once by hand. And now the formulas I'm going to be using are down here, but you don't have to do this ever again like this. We're just going to do it this one time so we can see how this formula operates. All right? Okay, so I'm going to take this and I'm going to paste it, honestly, into my Excel spreadsheet because I'm not doing this by hand. I'm going to make Excel help me out a whole bunch. Okay, now the first thing I want to know is, what we're trying to measure with this value is we're trying to measure how packed in they are to the mean or how spread out they are from the mean. So when I say spread, packed in, I'm talking about from the center, from the mean. I could use median as well, but that's a different type of one. So we're not going to do that right this second. Oops, hold on. Okay, so what I want to know is how far away are they from the mean? Now the mean, remember, we found it to be 74. Okay, I can find it again here, right there. Okay, so now if that's the case, what's the deviation? Deviation is how far every value is from the mean. So I take 60 minus 74. And now I'm going to give 74 dollar signs because I want to be able to drag this formula down the column. I want the blue box to change as I work down the column, but I want the green guy here, the 74, to stay the same. So if I do this, I'm going to go back up here, go to the right corner so it makes a little plus sign, and I fill down the column. There we go. Now look what happens if you find the sum of those values. It's 0. And it's always going to be 0. See, the deal is that if you're talking about deviation from the mean is the center. So shouldn't the ones that are high and the ones that are low, positive and negative, just kind of balance each other out? Okay, so this is no good. We want to know how far everybody is from that center, but we want to know it so that we can get a measurement of it. But it's never going to do us any good to find these deviations. Or is it? What we can do to make it positive is if we can take the deviation and we can square them. Equals that number squared. I'll be back here.